And now, Dr. Jacqueline McGlade from the Telethon Institute for Child Health Research in Perth. Jacqueline, thank you for flying all the way across the country.
It's a pleasure, thank you. Well, firstly, I'd like to thank the Brain Foundation and the generous donors that support this organisation for funding my application for a Brain Foundation research gift. These funds will go towards my research into medulloblastoma. This type of tumour is the most common malignant brain tumour in children and is the most significant cause of cancer-related death in these children. If we are to improve the outcomes of kids with medulloblastoma, it's imperative that we have a good understanding of what drives tumour growth, which will allow us to design better treatments. We've known for a long time that patients with medulloblastoma respond well to treatment, but others do not and are likely to die from their disease. In the past, we haven't had enough information to understand why this is, but recent research has revealed that although medulloblastoma may look the same down the microscope, when looked at more closely at the genetic level, they are not the same, and they are in fact at least 4 distinct subgroups of this disease, each arising when certain subsets of genes malfunction in specific cells within the brain. Previous laboratory studies have shown that mimicking these genetic changes in mouse neural stem cells can cause these cells to behave like medulloblastoma. However, this has never been demonstrated in human cells. In my study, I aim to transform normal human neural stem cells into cancer-causing cells by altering specific genes that are implicated in medulloblastoma. Not only will this research inform us as to how a normal cell can become a cancerous cell, but these cells will also become critical tools for future work. With these models, we can understand what genes are directly involved in the development and formation of medulloblastoma, which will enable us to select and test specific targeted drugs in order to find more effective therapies with reduced side effects for children with this disease. As many of you are aware, funding for scientific research is becoming more and more scarce, and unfortunately good research is often held back or unable to be conducted due to lack of funding. At this early stage in my research career, this Brain Foundation research gift provides an important start-up funds to gain preliminary data, which will allow me to apply for larger national grants to continue my research. Once again, thank you to the Brain Foundation and the generous donors for funding this investigation and supporting brain research in Australia.